Welcome to the rise of the machines. So, you all developers, are you afraid that machines will take over your job in the future? Yes? No? You should be. Well, maybe not. Let's see what machines can do nowadays to help us to automate our software development. But first, I want to start with a little bit of a disclaimer. So I wanted to talk a little bit about what this talk is not about. So maybe you're sitting in the wrong talk. Maybe you're expecting something else from me to say today. So I want to make that clear. If you think about automation, this talk is not about scripts. So writing cool automating scripts that automate a bunch of stuff on your servers. This is not what this talk is about. This talk is also not about learning some cool chef and puppet recipes. There's nothing in there from that angle of automation. I will not talk about automatic deployment. And this talk is also not about how you make your great build pipeline from beginning to end with one-click automation. This is not what this talk is about. There are other talks that cover all these topics, cool continuous integration patterns, stuff like that. This is what when you talk about automation, this is what you first think, automation in software development. But this talk is actually not about that. So what is this talk about? It's about everything else that we can automate in software development. So what I want to give you in this with this talk is some ideas what you can automate. So I've been talking to a lot of developers with inside Atlassian and also from other companies like Zero Turnaround and Hazelcast and some other stuff. And I brought some ideas what they automated, and I thought this is pretty cool to do a talk about that. And this is what this talk is about. But let's start with automation. So automation in general. So automation of our day-to-day lives. You think about maybe there's this automatic vacuum cleaner that is running around the house, cleaning your house when you're not there. Great automation stuff. The lawnmower that is running around. You probably heard of Nest. Stuff that is controlling the air condition at home. So all the stuff is great in automation. Or maybe you think about these great self-driving cars that are coming to our roads soon. We're not there yet, but probably in the future we will see that. What we actually have right at the moment is, for example, Volvo. Volvo has this not self-driving car, but intelligent car that stops actually when it detects a human in front of the car. So that car stops automatically, and that's a demonstration of this cool feature, what they have in their car. And oh my gosh, oh shit. Oh, sorry. So trust me, don't trust the bots too much. So this is what I want to say here. I hope nobody got hurt much by that one. Anyway, we're here on a software development conference. So let's talk about software development, automation in software development, right of the machines. I've been a software developer for years. My name is Sven. I work for Atlassian now as an evangelist. Means I'm traveling around speaking about cool stuff and take all the feedback that you got from our tools with me and put it and discuss that with our developers. So it's actually both ways, which is pretty cool. And I have my own career story about automation. You may have a different one, but actually this is my story. When I was studying in 1996, I was writing some build scripts with Make. This was actually the first time I got into a bit of automation in software development. So I was writing Make scripts. In 1998, I was actually working with a GUI builder. The first time, a GUI builder, I thought, okay, this is the way we go in future. Well, see that 18 years later, we're still not there yet with GUI builder, so maybe this isn't the way for the future. I don't know. Then automation, JUnit 2001. I wrote my first JUnit tests, which was pretty cool to write the small functional tests. Then 2004. Was for me, I wrote my first Ant scripts, later Maven. 2005, I actually switched from JDeveloper 2005 from JDeveloper, ball and JDeveloper. I don't know if someone remembers this good old days, to Eclipse. And I found that code generation, so that you can make getters and setters, generate them automatically, and do some cool refactoring stuff. I found that pretty cool automation stuff. Of course, 2006, I installed first time Hudson on a server, pointed it to my, at that time, CVS repository and my ARM script, and it built it automatically on commits, which I found this was pretty cool at that time. 2009, Puppet, played around with that. We didn't use that in production at that time, but we played around with it. And then 2011, we wrote our first Git hooks, and I would talk about Git hooks later, which I think is a pretty cool thing for automating something in your development workflow. And then 2013, Docker, also cool for automation. So I already said that, when you think about automation, you think about these things here: deployments, builds, and tests. And maybe you have some small scripts running on your servers, doing some small stuff. I don't know, looking at a file and writing an email to you when something happens. So I don't know. We all have written these small scripts. So this is when you think about what you think about automation. But actually, this is just the tip of the iceberg. You can automate much more than this. Actually, engineering health. You can measure your engineering health by doing some automation. You can have automated support, automated stand-ups. Yes, stand-ups, automated. Merging, code reviews, operation stuff. So all these things can be automated. And I will talk about this in this talk. I actually divided the talk in a few sections. So first I start with some coding bots. Then I will talk about testing, operation bots, service bots, and I will end with some reporting bots that people use. But the first automation that I want to tackle here, that I want to talk about, it's actually, I couldn't fit that in these categories. So it starts like that. You are actually starting at a new job. So first day, job, you start, you go around, meet a lot of people. They talk to you. They use all these new acronyms that you never heard of. At the end, your head might explode because all this information is coming to you. So you're happy, actually, after this 2 hours walking around, talking to people, learning all these new things, sitting at your desk and staring at your new computer. Hey, welcome. So what are you doing now? So first thing you do is actually, let me just the next 8 hours spent with installing some stuff on my machine. Actually, you install maybe the JDK, IntelliJ, some add-ons, Postgres, whatever you use in this new company. But actually, what is this company using? So you have to ask that. Well, maybe you don't have to ask that. We actually have this someone has written this cool list setting up a new development environment on a brand new Mac. So all this is in a list, so you can look it up in Confluence. And then it talks about, let's install some programs here. Good, okay, let's install some more programs. What's that? Of course, configure Maven. You have to configure Maven, and then start Maven and let Maven download the internet for you. That takes some time. We all know that. That takes a lot of time. So in between, you can set up your IDE. So you set up IntelliJ, do that, and then maybe some Postgres in between, whatever. And if Maven still installs or downloads the internet, well, you can go on and read all this blog posts here. Well, this is really a lot of work that you have to do by hand. So the first comment actually on that page, or the second comment, is, why are you not using Agent Charlie for a whole bunch of these steps to automate? So what is Agent Charlie? Well, meet Agent Charlie here. This is our Agent Charlie. So you can just go to a page in Confluence, download a small script, execute it, and what Agent Charlie does for you is installing, downloading, and configuring all these programs for you that you need at Atlassian. So you start Agent Charlie, it's doing all this stuff for you, and start Maven and downloading the internet. So what is Agent Charlie about? Well, it's actually a bunch of Puppet, Shell, and Ruby scripts together. We have that for OS X and for Ubuntu, and installing all this programs for you, configuring them, and you're able to run. So if you take that, without Agent Charlie, it's pretty hard to follow that list, and install everything step by step, how the things are done by, at Atlassian. And you probably can't find the newest version and stuff like that. Well, with Agent Charlie, actually, you can actually go. Let Agent Charlie do the work for you and go and meet your new colleagues, because social interaction at the beginning is much more important than installing stuff on your laptop. All right, so this is just the first example. Let's start with some serious coding bots that I brought with me. So if you think about what we do, we code. And if we talk to other people that don't know what we're doing, they think just, okay, these people are just sitting there and coding the whole day. Well, we all know that this is not true. This is not what we're doing. So we have a bunch of other stuff that we're doing. We're doing code reviews, deployments. We have to update our issues. We're doing build scripts, writing that, looking if the build failed, we have to change something. Maybe think about our branch strategy, make new branches, and all the things. So it's not just about coding. But there's a lot of stuff that we do. So let's get rid of one of these things. And it's updating the issue tracker. Well, you might say, wow, Sven, you're from Atlassian. Why are you saying that? Well, let's see. So a typical issue tracker workflow looks maybe like this. An issue is in to-do, it's in progress, it's in review, and at the end, it's done. This is the typical issue tracker workflow that you might have set up for your issue tracker. Well, our coding workflow, our development workflow looks maybe like this. At Atlassian, it looks like this. We're creating a feature branch, we code, we refactor, we make a pull request, and at the end, we merge the code back. So how does that work together? Our issue workflow with our coding workflow. So it works together like that. We're looking into our issue tracker. Well, set it in progress. We create the branch. We code refactor. We make a pull request. We go back to the issue tracker, set the issue in review, and then we may merge the code, and then we have to update the issue and say it's done. This is what we should do to update everything. But actually, what we do looks more like this. We create a branch, we code, we refactor, we make a pull request, we merge and say, oh, I forgot to update the issue tracker. Oh, well, let's do that. It's in progress, it's done. 5 seconds, issue done. Wow, fast. Wow, your performance looks great if you do it like that. But anyway, that's not the point. So the point is you should keep the team updated. Your team must know what you're working on, and maybe also some management want to know how things are going. So we've been looking at Atlassian, we've been looking at that and have thought about how can we make that more automated. So we thought about, okay, good. We make an experiment with this epoch motive things that you can put on your hat and then just think about, I'm updating the issue. The issue is now in progress. And what it does is actually, it drags the issue automatically over and set it in progress without using any mouse or other input device. Isn't that cool? It's great. We thought, wow, this is the way to go. Just send an epoch motive with all our Jira licenses, and this is great. Well, it's of course not great because you're just using your mind instead of the mouse. You still have to go to Jira and update the issues. So, but what a lot of tools actually issue trackers can do is this smart commits. So you write a commit, and then you write a commit message. You might write a command to your issue tracker. So, for example, GitHub, UTrack, Trello, Bitbucket issues, all these different issue tracker can actually do that. So it works like this. You have this issue. It's in to-do. You write the issue key, and then start progress, telling the issue tracker to put this issue into in progress. Start review, looks like this. And then at the end, you say, hey, fix this, blah, 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 issue number, and it transitions the issue automatically over. This is actually, this is the Jira notation, this is the GitHub notation here down there, but doesn't make a whole bunch of difference here. All right, this is cool. It's good. But, oh, well, so it's cool because you don't switch any tools. You don't have to switch between tools. You just write everything in the commit message, so you stay in your IDE or on your command line. But the downside is you're still sending commands to this robot. So you say, please update this issue. It's now in progress. You still say that. You still have to think about issue tracker. You still have to think about that. So let's go a step further. You can control actually the issue tracker by your action. How does that work? Well, so what we built actually for Jira and Bitbucket integration is when you create a branch and mention the issue key and the branch name, Jira makes a connection between those. And then if you create the branch, Jira sees that and say, okay, this issue is now in progress. Then you do a Bitbucket pull request. And also here, Jira sees that and say, hey, this issue is now in review. This is the workflow we're doing. And then at the end, we merge the code back, everything is fine. And of course, also here, it's done automatically. Well, we have implemented that, and I'm pretty sure that other vendors will do some kind of the same thing here. So if you're not using Jira Bitbucket, you just have to wait a little bit longer, but then you probably will also have that. If I first saw that and I heard that people in Sydney are working on that, I was going like this. Yay! Cool. But this is not the only thing that we have. We have also some other little, I call them little workflow helper. There are mostly some Git hooks that we use. So we, as I said, we're using this workflow of making a branch, doing a pull request, and then merge the code. And this is pretty essential. But there are some cool people sometimes that say, I don't have to do that. I'm this cool guy. I know what I'm doing. I'm just committing directly to the master branch. And then, of course, the build kicks off and says, the build is red. Ooh, damn it, our master branch is red. But anyway, I'm this cool guy. I can fix this issue in seconds. So 1 minute later, I commit again, and then the build is green. Whew, done. Cool. But there's probably this engineer that follows the rules and then create a branch right here. And then do some stuff, change the code, and merge and run a build on the feature branch, and all of a sudden the build is red. And say, oh, why? I didn't change that line. Why is the build red? Because you branched from a red build. So that's a bad surprise. Bad surprise. You have to look out and see why is it red, and then you find out, okay, it was red before, after, I don't know, 10 minutes or 15 minutes of investigating. But we can actually have a bot for that and say, okay, this bot doesn't allow us to have bad surprises. It doesn't allow us to branch from a red build. And we have that. There's a Git hook that looks at the continuous integration server and says, okay, the current build on the master branch is red. We're not allowed to branch from a red build. You're not allowed to create a branch. It's a Git hook that we've written. Another problem, or not problem, but another thing that we have, if you do your pull request, who's the best person to review your pull request? Of course, it's your friends, because they are friendly to you and say, oh, great work, Sven. We know you're a good programmer, so we approve all your pull requests. Well, anyway, these are not the best people to review your code, of course. But what you could do is you could go into the commit history and look at all these committers here. And these are actually the best people to review your code because they have changed this class or these files recently. But looking through all the files you changed in this pull request, well, that's not the best thing you do. But a bot can actually do that for you. Can look through and just say, okay, these are probably the best reviewers to invite to your pull request. So we have written a small free add-on for Bitbucket, which is auto-suggest reviewers. So based on that, it suggests automatically reviewers. These are the best people to review your code. So always invite the right reviewers, our second little workflow helper that we have. And then we have this loose rule of saying that minimum 2 or 3 people have to approve the pull request, and then we're able to merge it back. And we're checking on that. This is a rule that we have, that we say, okay, minimum 2 approvers, and then we have this Git hook that checks how many people have approved the pull request before we merge, and we have a minimum amount of approvers for our pull request. Not allowed to without that, we're not allowed to merge the code. That's our third little workflow helper. The last one is we have this special thing that we have different versions of our software running around on different servers. And if we patch an old version, so we maintain the old versions, if we patch an old version, we have to update also the other versions. Well, let me show you how our workflow works here. Well, you see we have a version branch, so we keep our version branches here. And then if we want to fix something in the version 1.1.0, we create, of course, a hotfix branch and merge back to the 1.0 branch. And then we have to merge the changes all the way back to the least stable branch, which is the master branch or develop branch or whatever you call that. And if you know Git, merging is quite easy. And normally, if you don't have conflicts in the first merge here, you probably won't have conflicts when you merge it upwards. So this is probably pretty boring work. And what are we doing if we have boring work? Well, we invite the bot to do that. So what we do is actually we merge just the first one here, and then an auto merge kicks in and merges the changes all the way up to the master branch. And actually, what they also do is they automatically kick off a build, and then it's built automatically, and the artifact is automatically deployed to our web page. So get some help with merge jobs, our fourth little workflow helper. So this should be for coding bots. Let's start with some test bots. So for a little bit smarter test automation. Well, testing. So we are actually trying hard to write beautiful code. I mean, we are engineers. We want to create great code. And when we think about creating a new class, we think about make that really, really awesome. So when I write my awesome class, well, maybe this is not a good example, but then I feel, oh, well, yeah, great. This class looks so great. It's so awesome. It's so good. Wow, great design, Sven. Woo. And that's what we want to do. We want to write beautiful code. Beautiful, maintainable code. But what happens actually with code is that when I've written my awesome class and I go on vacation and come back 1 month later, and I open my awesome class and say, I want to look at it again because I think it's so great. And all of a sudden, people have put more code on my class actually, and more code and more code and more code. So actually, what happens to my awesome class is over time, it gets polluted with other code that I wasn't anticipating or wasn't thinking of that this should fit into this awesome class. Well, but people do the stuff like that. People are doing this. So over time, we can do whatever we want, but code quality actually decreases. Whatever we have, deprecated methods, compiler warnings, code quality decreases. Decreases, yeah. But why? Developers don't want to write bad code on purpose. That's not what they want. They want to write good code. It's not on purpose that they do. But I think actually developers are just trying to solve their problems in that moment. In that moment, this is a good solution, looks good, and then we go on to the next problem. And don't think about, okay, somebody has actually written that class on purpose with this beautiful code. So what we do is actually we need someone to inspect constantly our code. And I call him Dr. Code. So Dr. Code is looking constantly at the code and inspecting the code and telling you something about the health of your code. Well, Dr. Code is, of course, not a human. It's, of course, a bot that looks at your code. And Dr. Code actually started when we wanted to move. We said we wanted to move to JUnit 4. So an engineer said, I don't want to see any new JUnit 3 tests. I just want to see new JUnit 4 tests. JUnit 3 tests, they are still there. Yeah, we cannot refactor everything to JUnit 4 with one step, but I don't want to see anything new. So no more JUnit 3 tests. So he wrote this little checker class here and installed and put it into Dr. Code that it's telling people you have added a new JUnit 3 test. That's not what we want to have. And people found that so useful that all of a sudden there were not just this checker class, but a lot of other checker classes that Dr. Code all of a sudden checks. Pretty amazing. And then we said, okay, good, maybe an email is not good enough. Build fail, also not, that's what we have. Build warnings, yeah, who's looking at that? So we thought adding a little bit of social pressure to people. So when you're caught by Dr. Code, you'll enter the hall of shame. I know with some cultures, maybe this is not the way to go, but we have fun and we think it's cool. So enter the hall of shame. So you got called out that you broke something, Dr. Code caught you, and then it's counting up. And then we put that on televisions, on wallboards, so everyone can see that. Actually, you see this guy in this yellow suit there, or yellow shirt there. He didn't want me to put that slide onto what Voxxed Zurich because he's, I think, 3 times or 4 times on that slide. So it's pretty bad. But he can get out the hall of shame, of course. If he fixes some JUnits retest and migrates them to JUnit 4, well, you can enter the hall of fame, which everyone wants to be in. All right. We're coders, and we're good at looking at code. So if I show you here 2 code snippets, a new version and an old version, you're pretty good at skimming through the code and see the difference, what somebody changed. And I don't have to ask you, you can see that's a magic number here. So you can see the difference directly from the old and the new version. So we are good at looking at code. But what about user interfaces? Where's the difference? Well, maybe it's not, you cannot see that, I highlight that. There's a different icon here for the calendar, so this is pretty hard to spot. But I guarantee you, designers can see that immediately. Designers are trained, their eyes are trained and say, hey, this line is 2 pixels off, and you say, what the I didn't see that. Okay, good. So what we did is actually, we wrote an image compare bot. So this bot is actually comparing an image from the database, which and takes an actual image from the actual software and compares those two. And then it gives them some warnings if it finds differences on that one. And then we have an easy reporting and said, hey, you broke something. Is that on purpose? So you get this report here and calls out here, there's a difference here. So is that on purpose? You say yes. Then it takes a new picture into the database and you say no, and then you have, of course, to fix it. So this is our image compare bot. But not just talking about this, we also have a lot of image compares, so we also have a lot of functional tests. And you can imagine Jira is now 14 years old or something around that, and our functional test ran actually for hours. They were pretty long functional tests. So what you do actually if they run for hours, you don't throw away tests because you don't know if they're important or not. So what you do is actually you run them in parallel. So you buy some new servers and run them in parallel. So you statically slice and dice your tests and say this bunch of tests runs on that server and that server and that server. And then it looks like this, which is of course faster than running everything on one server. But the thing is, you have to wait for the longest block to end to say, okay, now we go on with the next stage here in our build stage because we now know that the build is green. So we thought, okay, good, we have to fix that. We have to make that more dynamic. So we invented this functional test balancer, and we called that Hallelujah. And Hallelujah is just balancing, so it looks, there's a free server available, so I put that small functional test on that free server without not statically slicing, but dynamically allocating functional tests, so free test servers. So it looks like this. It's actually way faster than we had before, so we saved a lot of time by doing that. And at the end, we say, okay, we hopefully say, wow, cool, the build is green, so we are happy developers. Build is green. But sometimes, actually, it happens that we make some destroyed test or something like that, and then the build gets red, or maybe it happens that we say, okay, we change the line of code and the build is red, which is good. it's not really bad. We're not disappointing about that because we got caught before our customers have caught this bug. We caught it before. That's great. That's why we have this tests actually. But sometimes you also look at the test and say, I don't know why this test failed. I haven't touched actually this code here that makes this test run. I don't know what changed. I don't know. So what do you do? Any idea? You rerun the test. You say, okay, good, I rerun the test. And then the test is green again, and you say, oh no, damn it. I just have discovered here a flaky test. And the flaky test doesn't tell you anything about the test. It doesn't say about the software. Sometimes it succeeds, sometimes it doesn't succeed. Just say that this test is flaky for whatever reason it is. So what we did is actually we wrote a flaky test detector. So a detector that detects flaky tests. How does it go? So first we do our build here, and then we see, okay, there's a failing test. So what we do is actually we take this one test and rerun the test and say, oh, now it's green. So what we did is we just discovered a flaky test. So what we do is actually we continue the build because the flaky test doesn't tell us anything about the build. And the other thing is we put this test in quarantine so it doesn't be executed anymore for the next run. So we don't execute it the next time. But we want to fix the flaky test. So what we also do is we create automatically an issue and assign a person to it that this person has to look at this flaky test and say, maybe delete this test or maybe fix the test. And the Confluence team was using this flaky test detector for a while, for half a year actually, and we caught 817 flaky tests, and we put them in quarantine. They are not all fixed yet. That's the next step. We have to force people to fix them. But actually, we found these tests and looked at some of them and fixed some of them. So that's good. OK, enough about testing. Let's go one step beyond testing. And then this is the operation phase. So let's have a look at some ops bots, how bots can help us in operation. And we probably know the good old days when there was the development team and the ops team, and we as developers were just throwing our software to the ops team and say, hey, here you go, bye. It's your problem now, see ya. Well, we know with all this DevOps movement and stuff like that, these times are hopefully gone. We don't do that anymore. But also if we have a DevOps mindset, it happens that there's a problem happening and our operations teams discover that. They maybe got informed. They try to fix it, maybe restart this small service, and really didn't succeed. So what they do is they call the developer, and then the developer is fixing some stuff and deploy again, and then hopefully the software is back on track. But this is actually slow feedback loops. So we have to eliminate the ops in between here. So if something happened, we should inform the developer that is responsible for the service directly and see, hey, there's a problem with your service you just wrote, so please look at it and fix it. And then the developer can do the developer magic, and we fix it within, hopefully, minutes. And we actually use PagerDuty for that. In PagerDuty, you can point it to Nagios and stuff like that. And it knows actually who's responsible as a configuration and who's responsible for which service, and informs the right team. If this service fails, it knows this team is responsible and informs this team automatically, which is cool. This is not the automation bot I'm talking about, because the downside on that is in the age of microservices, where we deploy a new service each week, each day, I don't know. We have to do a lot of configuration. So we have to tell PagerDuty, hey, here's a new service, and this is the person responsible for the service, or this is the team responsible for the service. So what we actually did is we wrote a little bot that sits in between the developer and PagerDuty. And when we deploy a new service, we have to add the team name to the deployment descriptor. And this little bot looks at the deployment descriptor and puts the team name and the service name into PagerDuty, so PagerDuty knows who's responsible actually for that new service and can inform the right team if the service fails. Pretty cool. And this way we actually own our code end to end, so from one end to the other end. And this is what we want to have, actually. We want to be responsible for what we've written. All right, so, and if we're just in front of a big release. We're sitting there and we're well prepared for the release. And then someone come to us and say, hey, wait, are you prepared? Yeah, everything is fine. We put everything on staging server, so works great. Have you thought about the release notes? And say, the release notes. Yeah, sorry, I forgot that. So what you do is you can look into your issue tracker maybe and look it up, which version you have tagged with which issue. But if you want to really make sure that you catch everything that has been fixed, you have to look at your commit history and see which commits have been done and which issues have been fixed, and then get the issue description out of it. Well, there are some companies that have written bots for that, that actually looked at the commit history, look at the commit messages, and then combine that with the issue description and create the release notes automatically out of that, which is pretty cool. So, for example, Hazelcast is doing that. They are creating their release notes out of their GitHub issues. So these are GitHub issues, and then GitHub issues don't have any issue types, but they have labels. So they label stuff with feature and bug fixes, so they know this is bug fix and order stuff like that. Zero Turnaround for JRebel is doing quite the same thing. They use Jira and Bitbucket for it, and they use this issue types, and then you can see, okay, there's a fixed bugs, an improvement, new feature, and so on and so on. If you do things like this is of course the advantage that you don't have any surprises in your release, because the release notes are actually created out of your commit history. So everything that has been committed is also in the release notes. Cool. But I think it has more advantages, because people actually try to write human-readable issue descriptions. Sometimes you read an issue description and say, I don't know what this is. But if you use that really to show to your customer, this is pretty important that you write human-readable issue description. And another angle on that is that you have to think about the value that you deliver to the customer. And this makes you think about the customer. I think this is pretty good. All right. Enough about operation. Let's go into service and let's try some service bots. Our support actually, they answer support cases. And sometimes we say, okay, we don't know what happened, so please send us your log file. And then the support engineer is looking at the log file and say, I can't really see anything there. So what he does is he calls the developer. And the developer is scanning the log file, and not just we are good at looking at code. We also can scan log files pretty fast and say, oh, this exception, I know this, no, oh, what's that? What's happened there? So, and then look at it and then say, this exception, this null pointer exception here has caused this and this and this, and combine that with our knowledge that we have around the system and say, this is probably what happened and this is what causes this problem. This is good, this is great, but the downside is it pauses our work. It pauses work. We have to stop work, have to look at the log file, have to tell the support, we think this has happened, and go back to the customer. So instead of having this developer here, we have written a bot for that. We call the bot Hercules. What Hercules does is Hercules has a knowledge base, and this knowledge base lives in Confluence. So we have there the cause, the resolution, and then some steps here. But there's a machine-readable part here for Hercules. So Hercules, that's maybe a regex expression that Hercules can look at the log and then look at this here, make the regex expression onto the log file, and then apply that to the log file, and then see, okay, this is probably the problem. So we have all the knowledge base in Confluence, and Hercules can actually read that. So this way, actually, Hercules suggests some articles from our knowledge base to the support engineer, and then the support engineer can suggest it to the customer, and maybe if Hercules wasn't really good, updates the knowledge base. You might say, why are not just putting it out to the customer? Don't have the support guy, just let the customer work with Hercules. Yeah, we wanted to make the knowledge base stable first, but then we tried with some customers, and look what one customer wrote. They wrote, well, fuck me, the robot was right. I reduced the memory available for Jira Confluence, and things work. This is truly a magical day. And our support thought, this is so great feedback. We create a T-shirt. Well, fuck me, the robot was right. And run around with pride on it. All right, talking about coding, being in the tunnel, being in the flow, and then somebody comes and say, hey, can I just interrupt you for a second? And then say, oh, I'm not in the flow anymore. Spotify has the same problem. So what they did is actually, in front of the development room, they have this terminal. So if somebody goes in, and then they can report their issue directly into this terminal and say, oh, I have a problem here and there. And the cool thing is also they press submit. And then the cool thing is there's a printer here. And then they print a physical physical paper to take that the person can take with this issue key on it and say, hey, have you worked on this issue key? This way they doesn't get interrupted so much anymore. All right, report bots. Why? Because manual reporting sucks, actually. And I was talking about that in the beginning about automating stand-ups. And you might think, Sven, you're crazy. Automating stand-ups is about the human interaction here. You cannot automate a stand-up. Well, you'll be right. Of course, you cannot automate a stand-up like it is. But there are some problems actually with stand-ups. For example, some people are just talking too long. They are talking and talking and talking and talking. So the stand-up takes too long. Another problem is that you have to remind people, hey, remember there's a stand-up today at 11 o'clock. I know we have to drag you out of the kitchen each day, but remember come to our room, we have a stand-up. Setting up VC calls sucks. Just remember, oh yeah, Tom is remote today, so we have to start a VC call and then chat maybe with Tom and say, hey, can you go on this link and start the VC call? Or then also working in different time zones. And believe me, I'm working with people in Australia and I'm working from Europe, and this time zone doesn't really match. So having stand-ups with different time zones that far apart from each other, that's not really something really good. So let's fix some of these problems here. That the stand-up takes too long. People are talking too long. So this is actually the only physical bot that I have, so called Stand-Up Buddy. What it does, it starts vibrating after a certain time, and then you press on the head there, and then it restarts. And then if it vibrates, people have to pass the Stand-Up Buddy on to the next person, so people don't talk too long in stand-ups, which I thought is pretty cool. So this is Stand-Up Buddy. It helps us to make stand-ups shorter. But what should we do with people that are missing stand-ups, that say that we have to drag out of the kitchen and say, hey, the stand-up is happening? So what a developer at Atlassian wrote is an extension for Chrome, and you can put in a certain time and a URL, and it's called Chrome tab. And we pointed to Pandora or some other music streaming service. And if you hear AC/DC playing 1 minute before the stand-up, you know, okay, it's now our stand-up, so let's go to the stand-up. So it starts automatically, this tab in Chrome, and plays the music. And if you hear, I don't know, Taylor Swift playing, you know it's a market team stand-up, and you don't have to go in there. And we use actually the same extension for setting up VC calls. So every team has this televisions and then setting up a VC call. Also here, we have a fixed URL for remote people to jump on the call, and it starts automatically the video conferencing, and we don't have to do anything about it. So stand-up report bots, good for co-located teams, and then also good for distributed teams starting the camera. But what about if you work in different time zones? Well, there's no really good solution for that, but we tried hard. So actually what we have is we're telling a bot what we've been doing. So if we work in Europe, for example, we're telling the bot at the end of the day, this is what we've been doing, and then the bot is keeping that, and then it gets stay in Australia, and then Australia can ask, hey, what's the team update from all the teams all over the world, and can read that. And we put that actually into our communication tool. So it's not an extra tool or extra page that we have to go in. We put that in our chat tool. So this is a stand-up bot. You just write /standup, then you write your text, and then it's recorded automatically by the bot, and then you just write /standup, and then it shows you all the updates from the whole team that is in that specific room. And chatbots are actually everywhere. If you use chat, some modern chat solution like Slack or HipChat, there are so many integrations that you can have. So for example, build failures, if the build fails, put that into your chat room, discuss the build failure, and see who's responsible for that. Deployments, you can connect your deployments to your chat room, and you can see who deployed what. And then also, if some exception happened on the production system, you can put that into the chat room and discuss why this exception happens. We're actually using a Sentry add-on, so we use Sentry to capture this, to capture our log files there, our exceptions, and then put that into our chat room. Well, 45 minutes, and I told you that bots are everywhere. It's not just into our continuous integration, continuous delivery pipelines, sitting automation. We also have bots in coding, in testing, operations, service bots, and report bots. So you might say, hey, where do I get all these bots that you just showed? Well, we have written them. There are probably a lot of people that also have written other bots. Do you have to reinvent the wheel? Well, I was talking to a lot of people, and they say, yeah, we looked at some automation things that other people have written. But often, if you go to GitHub and find that that's unmaintained code, it's not working in your environment, and then also, it solves a very specific problem for that company that doesn't apply for our team. So maybe you end up in writing your own little bot. But this is not the problem, finding a bot or writing it yourself. There's a bigger problem here, why we don't automate stuff that much in software development. And this is the time. We never take time. We never have time to automate stuff. Let me tell you a short story here. So, as I said, Jira, very old. We have a lot of technical debt that we are carrying around with us. So our chief engineer for Jira said, okay, you can use 10% of your time, of your sprint time, to actually fix stuff in engineering health. So fix some issues that we have. But what actually a developer came up with here, Philip, he actually wrote this Docker code. So he automated actually this fixing of engineering health. So in his 10%, he wrote this automatic bot that people now, also during the main sprint time, fixing stuff. They don't want to be in the hall of shame. What we also do is hackathons. Every quarter, we're doing something we call Ship It, 24-hour hackathons where we fix stuff in our products, but also for our coding workflows, which works better for us. And please, if you have bots, if you write automation code, treat your bots well. It's not just like you write it, you deploy it to your server, then you're done. You should treat your bots very well. So please put everything in source control. Everything that you write, put it in source control, obviously. But also do code reviews. Let other people know how your automation code works. If you change something, do code reviews. So treat your automation code like production code. Write tests, automated tests. So if another person changed this bot, he or she knows that they didn't destroy anything of your functionality. And then please have deployment scripts for your automation code, so people know actually where to put and in which directory this automation code goes and stuff like that. Well, because when we talk about bots and if machines will take over our jobs, well, building software is a craft, and we have some tools, and tools can help us to do a better job in software development. But creating actually customer value, this is an art. And I don't think actually that bots will take over creating customer value. That's still us coming up with innovative solutions for our customers. So this is an art. But don't be so sure. Don't be so arrogant and say, hey, we are the masters, the bots don't understand us. don't mess with your bots. Don't treat your bots like this. I want to end with that. This is not very nice. Be nice to your bots, actually. Don't do that. That's so unfair. Don't do that with bots, with poor bots. Because we actually know what happens if we treat bots like that. Things like that happen, and one day the bots will take over if you treat them badly. All right, that's it. Thank you very much. Thanks for your attention.